What if I told you that a guy from Ohio built cylinder heads so revolutionary that the NHRA had to rewrite their rulebook just to stop him? We're talking about technology that Chevrolet's own engineers never attempted, heads that flowed 20% more air than anything GM ever produced, and an engine design that made 900 horsepower from just 500 cubic inches when everyone else was struggling to hit 800. This is the story of Warren Johnson and the Splayed-Valve small block heads that literally outsmarted one of America's greatest engine designs. Inch now it's on and picture this. It's 1995 at an NHRA Pro stock event. The staging lanes are filled with the usual suspects, factory-backed teams with million-dollar budgets, professional crew chiefs with decades of experience, and engines built to the absolute limit of the rulebook. Then Warren Johnson rolls up with something nobody had ever seen before. Under the hood of his Oldsmobile Cutlass sat a small block Chevy that looked wrong. The valve covers were wider. The rocker arms sat at strange angles, and when he fired it up, the sound was different, sharper, more violent, like the engine was barely containing something explosive inside. The competition thought Johnson had lost his mind. Pro stock racing in the mid-90s was about refinement, not revolution. You took proven designs and optimized them within an inch of their lives. You didn't reinvent the wheel. You certainly didn't redesign the fundamental architecture of an engine that had been winning races for 40 years. But Warren Johnson wasn't interested in conventional wisdom. He was a professor of mechanical engineering who approached racing like a physics problem, and he'd just solved an equation that nobody else even knew existed. Now let me set the stage for you. By 1995, pro stock racing had become a technological arms race where victory was measured in thousandths of a second. The class required naturally aspirated engines, no turbos, no superchargers, no nitrous. Just pure mechanical efficiency squeezed from 500 cubic inches of displacement. Most teams were running big block engines because the cylinder head design allowed for larger valves and better airflow. The small block Chevy, despite its racing heritage, had hit a wall. Its parallel valve cylinder head design, unchanged since 1955, simply couldn't flow enough air to compete at the highest levels. Tuan. The problem was geometry. In a conventional small block head, the intake and exhaust valves sit parallel to each other, both perpendicular to the piston. This design worked brilliantly for street engines and even moderate racing applications. But when you're trying to extract maximum horsepower, those parallel valves become a bottleneck. The intake ports have to snake around the push rods, creating turbulence. The valves can only be so large before they hit each other or the cylinder walls. And the airflow path from the intake manifold to the combustion chamber involves multiple direction changes that rob power. And every pro stock racer understood these limitations. Most accepted them as the price of running a small block. The smart money was on big blocks with their canted valve designs that Chevy had been refining since the 427 mystery motor of 1963. But Warren Johnson looked at this problem differently. He wasn't bound by what Chevrolet had designed. He wasn't limited by what was commercially available. He was an engineer with access to CNC machines and a radical idea, when what Johnson proposed was audacious in its simplicity. Instead of keeping the valves parallel, why not splay them outward at 15-degree angles? This would create more room for larger valves. He could fit 2.35-inch intake valves where others were maxing out at 2.08 inches. The intake ports could be straightened, eliminating the tortuous bends around the push rods. The combustion chamber shape would be more efficient. The entire breathing apparatus of the engine would be transformed. But here's where it gets interesting. This wasn't just about bolting on different cylinder heads. The Splayed-Valve design required a complete reimagining of the small block's valve train geometry. The rocker arms had to be redesigned and repositioned. The push rods needed different angles and lengths. The camshaft profile had to be recalculated to work with the new valve angles. Even the intake manifold required custom fabrication to match the relocated ports. Johnson wasn't modifying an engine. He was redesigning it from first principles. The development process was methodical and expensive. Johnson spent countless hours on flow bench testing, measuring exactly how much air moved through various port designs at different valve lifts. He experimented with different valve angles. 10 degrees wasn't enough improvement. 20 degrees created packaging problems. 15 degrees was the sweet spot. He tried various combustion chamber shapes, port volumes, and valve seat angles. Every change was tested, measured, and analyzed, and the machine work required was extraordinary. These weren't heads you could order from a catalog or modify in a typical race shop. Johnson used 5-axis CNC machines to cut ports that would have been impossible to create by hand. The precision required was measured in 10,000ths of an inch. 1 degree of error in valve angle would cause catastrophic failure. The metallurgy had to be perfect. These heads would see cylinder pressures exceeding 1,500 psi and temperatures that could melt aluminum diastin. When Johnson finally had working prototypes, the results were staggering. On the flow bench, his Splayed-Valve heads moved 420 cubic feet per minute at 0.900-inch valve lift. Contemporary parallel valve racing heads peaked around 350 CFM. That's a 20% improvement, massive in a sport where 2% gains were considered significant. But airflow was only part of the story. The straighter ports maintained higher air velocity, improving cylinder filling at high RPM. The larger valves reduced pumping losses. The optimized combustion chamber shape improved burn efficiency. The first dyno pulls were almost unbelievable. While other pro-stock small blocks were struggling to reach 750 horsepower, Johnson's Splayed-Valve engine screamed past 850, past 875, and finally settled at 900 horsepower from 500 cubic inches, naturally aspirated, on gasoline. The torque curve was equally impressive, over 650 lb-ft, with a table flat plateau from 6,500 to 8,500 RPM. The engine would rev cleanly to 9,800 RPM, a full 1,000 RPM higher than most contemporary pro-stock engines, and outstanding, but horsepower on a dyno doesn't win races. The real test would come at the track. Johnson debuted his Splayed-Valve engine at the 1995 NHRA Winter Nationals in Pomona, California. The qualifying sessions were a revelation. While other cars were running mid-690s in the quarter mile, Johnson clicked off a 6.88, then a 6.6. By Sunday's final round, he'd reset both ends of the national record with a 6.849 at 199.15 in Ampoitonachquanon. The competition was stunned. How was a small block Chevy, an engine design most had written off as obsolete for pro-stock racing, suddenly the fastest combination in the class? Crew chiefs from other teams crowded around Johnson's pit area, trying to get a glimpse under the hood. But Johnson kept the heads covered, revealing nothing about his secret weapon. NAs. The 1995 season progressed. Johnson's dominance became undeniable. He won 5 national events. He reset the national record 8 times. He qualified number 1 at 12 of 16 races. His Oldsmobile became the car everyone feared, the combination nobody could match. Other teams threw money at the problem, hiring additional engineers, buying more sophisticated equipment, testing endless combinations. Nothing worked. Johnson's Splayed-Valve small block was simply superior. Next, the technical advantage was multifaceted. Beyond the raw airflow numbers, the Splayed-Valve design offered benefits that only became apparent in competition. The straighter intake ports provided more consistent cylinder-to-cylinder distribution, crucial for maintaining the delicate balance required in pro-stock. The improved combustion chamber shape allowed Johnson to run more aggressive ignition timing without detonation. The higher RPM capability meant he could run different gear ratios, optimizing acceleration for each track. And the Splayed-Valve heads also changed the engine's breathing characteristics in ways that affected the entire car setup. The improved high RPM power allowed Johnson to run a looser torque converter, which reduced heat and improved consistency. The broader torque curve meant less gear shifting precision was required. The engine would pull hard even if the shift points weren't perfect. The reduced pumping losses meant better fuel economy, allowing Johnson to run less fuel and reduce weight. But the most significant advantage might have been psychological. Other teams knew they were at a fundamental disadvantage. No matter how well they prepared, how perfectly they tuned, how flawlessly they drove, Johnson's Splayed-Valve engine had a built-in superiority. It's demoralizing to know you're bringing a knife to a gunfight, even if it's the sharpest knife ever made. Nantian, the NHRA officials found themselves in a difficult position. Pro Stock was supposed to showcase door slammer technology relevant to production cars. But Johnson's Splayed-Valve heads had no connection to anything Chevrolet had ever built. They were pure racing technology, as exotic as Formula One components. Other competitors argued that if splayed valves were legal, why not overhead cams? Why not 4 valves per cylinder? Where did you draw the line? Then behind closed doors, the politics were intense. General Motors wasn't happy that an independent racer had out-engineered their factory teams. Ford and Chrysler teams complained about competing against technology they couldn't buy or develop quickly enough to match. The aftermarket cylinder head manufacturers, who sold parallel valve heads to dozens of teams, saw their products becoming obsolete overnight. Johnson, meanwhile, kept winning, and with each victory the pressure on NHRA increased. The 1996 season saw Johnson expand his advantage. He'd refined the heads further, finding another 15 horsepower through subtle port reshaping and valve seat modifications. His engines were now making 915 horsepower, and he'd developed a second-generation design with even more radical valve angles that he was testing in secret. Shenzhen, the rulebook change came down in October 1996. Starting with the 1997 season, Pro Stock engines would be required to use Strauss conventional valve angles as originally designed by the manufacturer. In one sentence, the NHRA had banned Johnson's Splayed-Valve heads. The official reasoning was about maintaining the class's relevance to production vehicles. The unofficial reason was that one team had gained an insurmountable advantage that threatened the competitive balance of the entire class. And then Johnson's response was philosophical. He'd proven his point. He'd shown that accepted wisdom could be challenged, that revolutionary thinking could triumph over evolutionary development. He'd forced billion-dollar corporations to acknowledge that one engineer from Ohio had outthought their entire development teams. The Splayed-Valve heads went into his personal museum, a monument to innovation that was too successful for its own good. But the impact of Johnson's Splayed-Valve heads extended far beyond his own racing career. The technology forced the entire industry to reconsider cylinder head design. While splayed valves were banned in Pro Stock, the concept influenced development in other racing classes. Top Fuel and Funny Car teams incorporated similar principles into their billet heads. NASCAR Sprint Cup teams pushed for canted valve designs that borrowed from Johnson's geometry. Even Chevrolet eventually developed the LS7 and LS9 cylinder heads, with subtle valve angle changes inspired by Johnson's work. And the data from Johnson's development program became legendary among engine builders. His flow bench numbers were cited in engineering textbooks. His port designs were analyzed in CFD software to understand why they worked so well. Young engineers studied his approach, not just the splayed valves, but the systematic methodology he used to challenge conventional design. The Splayed-Valve heads also changed how the NHRA wrote rules. The sanctioning body realized that vague regulations about a flyer's stock appearing components weren't sufficient when dealing with sophisticated engineering. Future rulebooks included specific measurements, angles, and dimensions to prevent another Warren Johnson situation. The rules became proactive rather than reactive, anticipating potential innovations before they could dominate. In the wider context of American motorsports, Johnson's Splayed-Valve heads represented a pivotal moment. They proved that independent innovation could still triumph in an era of corporate racing. They showed that fundamental engineering principles could overcome brute force spending. They demonstrated that one person with the right idea and the skills to execute it could revolutionize an entire industry. Titant, the story resonates beyond racing because it embodies classic American themes. The lone inventor challenging the establishment. The David versus Goliath narrative of one team against the factories. The triumph of intelligence and creativity over resources and tradition. Johnson didn't just build better cylinder heads. He proved that revolutionary thinking was still possible in a mature technology. And today, Warren Johnson's Splayed-Valve heads are remembered as perhaps the most dominant technical advantage in pro stock history. They're displayed in museums as examples of American racing innovation. Engineers still reference them when discussing cylinder head design. And in the paddock at NHRA events, old-timers still talk about the 2 years when one man's imagination made the best engine builders in the world look obsolete. The broader lesson is about the nature of innovation itself. Johnson didn't accept the constraints that everyone else considered immutable. He questioned why valves had to be parallel, why ports had to bend around push rods, why small blocks couldn't compete with big blocks. By challenging these assumptions, he created something genuinely revolutionary. The fact that it was banned doesn't diminish the achievement. If anything, it confirms just how superior the design was. Modern pro stock racing has evolved into something even more specialized, with purpose-built engines that share nothing with production cars except basic architecture. But the spirit of Warren Johnson's Splayed-Valve heads lives on in every racer who looks at accepted limitations and asks, why? It lives on in every engineer who refuses to accept that traditional designs can't be improved. It lives on in every underdog team that believes intelligence can overcome resources. The Splayed-Valve small block wasn't just Warren Johnson's most advanced engine design. It was a masterpiece of engineering that challenged everything the racing world thought it knew about cylinder heads. It proved that revolutionary innovation was still possible in an engine design that was 40 years old. It showed that one person with vision, skill, and determination could outsmart entire corporations. And it demonstrated that sometimes being too successful is the greatest compliment an innovation can receive. The irony is that by banning Johnson's heads, the NHRA inadvertently created a legend. Had the Splayed-Valve design been allowed to continue, other teams would have eventually copied it, refined it, and normalized it. Instead, it remains frozen in time as the ultimate nust what if. The technology that was too good to be legal, the innovation that broke the sport, the cylinder heads that outsmarted everyone. Warren Johnson continued racing successfully for another 2 decades, winning multiple championships with conventional equipment. But those who knew him best say he was most proud of those Splayed-Valve heads. They represented pure engineering achievement, unconstrained by politics or tradition. They were proof that in American motorsports, innovation could still change everything, even if only for a brief, brilliant moment. Nenished in the Splayed-Valve story reminds us that true innovation often comes from questioning fundamental assumptions. Everyone accepted that small block Chevy valves had to be parallel because that's how they'd always been. Johnson asked why, and in answering that question, created something extraordinary. That willingness to challenge accepted wisdom, to imagine different possibilities, to execute radical ideas with precision, that's the essence of American racing innovation. What revolutionary idea is sitting out there right now, waiting for someone brave enough to challenge conventional thinking? What accepted limitation is actually just unexamined tradition? What impossible problem has a solution that nobody's considering because it violates some unwritten rule? Warren Johnson's Splayed-Valve heads prove that these opportunities exist, waiting for someone with the vision to see them and the courage to pursue them. In those heads now sit in private collections and museums, testament to a moment when one engineer's imagination exceeded the sport's ability to accommodate it. They're beautiful in their complexity, the CNC machined ports flowing in graceful curves, the precisely angled valves creating a geometry that seems both alien and inevitable. They're artifacts of a time when racing innovation could still shock the establishment, when individual genius could triumph over corporate resources. The next time you hear a small block Chevy at full throttle, remember that for 2 glorious years, Warren Johnson made that iconic engine design do something its creators never imagined. He took Ed Cole's 1955 masterpiece and reimagined it for the extreme demands of pro stock racing. He proved that even the most successful, most developed, most understood engine in American history still had secrets waiting to be discovered. That's the legacy of the Splayed-Valve heads, not just the horsepower numbers or the race wins, but the proof that revolutionary innovation is always possible. In a world of incremental improvements and evolutionary development, Warren Johnson delivered a revolution. The fact that it was too successful to survive doesn't diminish the achievement. If anything, it amplifies it. Because being banned for being too good, that's the ultimate recognition of engineering excellence. What's your take on Johnson's Splayed-Valve innovation? Was the NHRA right to ban them, or should innovation be unlimited in racing? Drop your thoughts in the comments below, and don't forget to subscribe for more stories of revolutionary engineering that change motorsports forever.